In this video, I'm going to graph the function f of x equals x plus 6 times x plus 2 over 2x plus 5 times x plus 1. And in doing this by hand, I want you to see all the moving parts, how they work in unison, how you can reason out some of these things, and also know that these are messy and they're not perfect. And while you should be able to talk through this in a fashion similar to how I am, also know that the textbook literally says you should have a graphing calculator of some sort just to check stuff, because sometimes these have little quirks to them. And we'll talk about that. But I'm going to start by finding the vertical asymptotes. Now remember, the vertical asymptotes are anything that make the denominator equal to 0. So I'm going to start by taking these two factors in the denominator and set them both equal to 0. So I have 2x plus 5 equals 0 and x plus 1 equals 0. The bottom one's definitely the easier. I have a vertical asymptote of -1, and if I subtract 5 from both sides and divide by 2, I end up with x equals -5 halves. So I'm going to make my vertical asymptotes in blue. So x is -1, so it'll never touch this line, up or down. And then I also have that -5 halves, or -2.5. So 1, 2. So this is skinny right here. This is going to be interesting to see. All right, now, like I said, this is by hand. This is not going to be perfect, but we're going to do the best we can. All right, so I have my two vertical asymptotes. So let me label this with vertical asymptotes. Let's also add to that a horizontal asymptote. So if I look at this, I have x times x is x squared on top, and 2x times x is 2x squared on the bottom. The degrees are the same, which means I have to look at the leading coefficients, and this is 1 times x squared and 2 times x squared. So my ratio would be 1/2. Since they have the same degree, x squared, I look at the leading coefficients, and that's 1/2. So I have a horizontal asymptote at 1/2. So if I come through here, 1/2. Now do remember what I said, that vertical asymptotes are absolutes. They will never have a value at that given x value. Horizontal asymptotes are soft, and sometimes you will have an actual value at the horizontal asymptote in the middle of the graph. Horizontal asymptotes specifically look at end behavior towards extreme values of x. But I have vertical asymptote, I have my horizontal asymptote. This is kind of setting up a framework. Next, I will look for zeros. When does this graph touch the x-axis? Well, for fractions, anything that makes the numerator 0 will make the whole fraction 0. So I'm going to take those two factors on top and set them equal to 0. And when I do that, I get zeros at -6, -6 to both sides, and -2, -2 to both sides. And so I have values, specific values on this graph at -2. So that's right there, already in that little in-between line right there. And then at -6, so that's 3, 4, 5, 6, right there. Okay. So let's see here. Just based on what I know about these, and as close as this is to the horizontal asymptote of 1/2, my guess is that we're going to have something like this. It's going to come up here. It's going to cross this line as it gets infinitely close to that horizontal asymptote. That's my assumption. Now, working with that, let me erase this little errant mark there. Working with that, when I look at these vertical asymptotes, both of these have a multiplicity of 1. And what we said was when you have a vertical asymptote with multiplicity 1, the values on either sides have to be opposite signs. And so what you'll see right here is that this is going super negative. If this is going super negative, then the values on the other side of that asymptote have to be positive, which means it's coming from down or up here because it has to be positive. So this is coming down. And what I see is that this is coming down. It actually comes down and it touches the x-axis down here. The 0 also has a multiplicity of 1, which means it's not bouncing off. It is, in fact, crossing. And because it is, in fact, crossing, it's not crossing again. There's only one x-intercept, which means this actually has to continue down forever, which means it should be hugging this other side right here. So it's hugging this other asymptote. So it does kind of like a really flat S shape. It kind of comes down, it crosses over somewhere, across the x-axis right there, and kind of curves over to this other asymptote. Now, this asymptote also has multiplicity of 1. And so as I look at that, I know that, something I said before, that values on either side of asymptotes of multiplicity 1 have to have opposite values. So once again, this is really negative, which means the value on the other side has to be positive. So it actually has to be back up here. And here's what I know about this. This is coming down. Oh yeah, I have zeros, but one thing I haven't checked yet is a y-intercept. We know how to find y-intercepts as well. So y-intercepts is when the x value is 0. So I have 0 plus 6 times 0 plus 2 over 2 times 0 plus 5 multiplied by 0 plus 1. So this is 6 times 2, which is 12. That is 0, so I have 5 times 1, which is 5. So my y-intercept is 12/5, which is 2 2/5, about 2.5. So if I go, let's mark that point, 2.5. So 1, 2.5. It's about right there. I said that because I know that this, oops, let me put that back there. I know that I have to come from a positive infinity up there, and as this comes down at some point, it's going to cross the y-axis, and the answer is it crosses right there and starts to flatten out. Now, I'm getting into the realm of horizontal asymptote. Now, it's not clear to me if it's far enough down that this is considered an extremity to where it's just going to now hug. It's now going to hug the horizontal asymptote. I have seen some weirdness in graphs where sometimes you'll see it actually dip down below the, I've seen them dip down below the horizontal asymptote and approach it from the bottom. I've seen that happen before. So that's one of the reasons why we say check. But my guess is that it's just going to, hug it from above. And yeah, so I think that is what our graph is going to look like. Basically that, using all the properties we've talked about. Yeah, and if we pull it, let me bring it up. So yeah, when we pull it up right here, you can see that we actually did a pretty accurate description. Now I'm going to add a little bit of context to this. Let's add our asymptotes in so we can see them. So there's our y equals 1/2, our horizontal asymptote, and you can see it hug it pretty well right there. We can do our vertical asymptotes. We had x equals -1. You can see that asymptote right there. And then we can see x equals -2.5. And sure enough, we can see with those asymptotes in there, we did a pretty good job with that. So just going back one last time, how do you graph one of these? So when you have one of these examples, things that we want to check, you want to check vertical asymptotes. We typically do all asymptotes with the dotted line. You want to figure out your horizontal asymptotes. Which of those three cases is it? You want to find your zeros. That can help add context. And I did it a little bit late in the game. I should have remembered earlier, but you also want to find y-intercepts. Now, it is distinctly possible. You may not have any y-intercepts. You may not have any zeros. There's all kinds of oddities that can come out of this. So just be aware of this. And the last thing, we had to think a lot about multiplicity of zeros and multiplicity of asymptotes. So make sure you pay attention to those details and what it means to have odd or even multiplicity for both zeros and asymptotes.